Today we're going to talk about rational exponents. Another name for rational, remember, is fraction. So we're going to look at fractional exponents. And what we're going to be able to do today is to rewrite a radical into a rational exponent. We're also going to be able to simplify those rational exponents. So let's go ahead and take a look at a radical. Let's say we have the third root of 125. If we look at the 125, the radicand, this has an exponent of 1 to start. So we can say, really, this is the third root of 125 to the first power. To write this as a rational exponent, or fractional exponent, we're going to write the radicand, 125. We're going to take the exponent that it has, 1, and we're going to take that and divide it by the index, which is 3. So we can write this as a 125 to the 1/3 power. And that's rewriting it as a rational exponent. We can do the same for variables. Let's say we have the fourth root of x to the third. To write this as a rational exponent, we have our radicand, which is x. Our numerator is 3, since it's the exponent of x. And our index was 4, which is going to be our denominator. So we have x to the 3/4. Finally, let's go ahead and take the fifth root. And what happens if we were to give two variables under the radical? So maybe we have a squared and b to the third. What we're going to do here is we can write this as the quantity of a squared b to the third. We can think of this entire radicand to the first power, so we have it to the 1/5. Using our exponent rules, we know that we can take this 1/5 and multiply it to each of these exponents. So we can rewrite this as a to the 2/5, b to the 3/5. And that would be an example of two things being multiplied together in our radicand. Now let's go ahead and move on to our simplifying rational expressions. Well, here we're going to start out with a base, and we're going to give it a rational exponent. Say I have it to the 1/2 power. Well, hopefully, we can convert this back into our radical form. Eventually, hopefully, though, we'll see that we don't need to do this. We can go ahead and simplify this without rewriting it. So if I look at 64 to the 1/2 power, our index is 2, since that's my denominator. My radicand is 64, or my base, and this is to the first power. Remember, we don't need to write that 1, it's understood. So we're looking at the square root of 64, which is 8, and that is our answer. Let's go ahead and take a look at another one. What happens if I take 64, say, to the 1/3 power? Well, here we can write it again as the third root of 64, and the third root of 64 is 4. And there's our final answer. Let's go ahead and take a look at variables with rational exponents. Say I give you x to the 2/5. Here I can rewrite this as the fifth root of x squared. Since 2 is smaller than our index, we cannot reduce that. In our next example, however, we're going to be able to reduce it. So let's take x to the 6/5 power times y to the 2/5 power. Here, since our denominators are the same, we can pull that out as taking the fifth root of x to the 6th, y squared. X to the 6th, since my exponent is larger than my index, I can go ahead and break this apart into a perfect fifth. Remember, if the exponent is divisible by the index, it's a perfect root. So I'm going to start decreasing this until I get to an exponent that's divisible by 5. So I have x to the 5th times x. Remember, 5 plus my 1 gives me 6, and my y squared. Since 2 is smaller than the 5, just like my previous example, I'm not going to be able to simplify that. Finally, I can take my x to the fifth out, and I end up with x fifth roots of x y squared. Remember, I don't need my absolute values since I started with an odd index. Let's go ahead and take a look at a little more complicated simplification. Let's make that to the 3/4 power. So if I have 16 to the 3/4 power, I can rewrite this as a radical. I'm taking the fourth root of 16 to the third. The nice thing with radicals is that if I have an exponent on the inside, I can bring that to the outside. So I can think of this as the fourth root of 16 quantity to the third. Because remember, if I look at a radical or a rational exponent, my top number was the numerator, was the exponent, my bottom number was my index. It doesn't matter if I take the square root of this and then take it to the first, or take it to the first and take the square root of that answer. Same thing's happening down here. I can break this up. So the fourth root of 16 gives me 2, and I can take that to the third power, and 2 to the third power is 8. Normally, it's a lot easier to take the root of the number, then take it to the exponent. That way you're not using and working with a very large number. Let's go ahead and take another look at one of those. If I have negative 32, say to the 3/5 power. I'm going to take the fifth root of negative 32. I'm going to take that all to the third power. The fifth root of negative 32 is negative 2, and that's going to be to the third power. Negative 2 to the third gives me negative 8. Let's go ahead and take now a look at multiplying. If I say I had 5 to the 1/2 times 5 to the 1/2 power. To simplify this, I can write these both as radicals. So I have the square root of 5 times the square root of 5. I can remember my multiplication rules. I'm going to multiply the radicands. So I'm going to get the square root of 25, and the square root of 25 is simply 5. And there's my answer. We can take another look at another example. If we take 6 to the 1/3 power times 36 to the 1/3 power. Here we have the third root of 6 times the third root of 36. If I were to multiply 6 and 36, I get a rather large number. So instead, let's think about 36. If I think about 36 as being 6 squared, I'm going to have the third root of 6 squared. Now if I multiply 6 and 6 squared, I'll end up with the third root of 6 to the third. And 6 to the third, if I take the third root of that, I'm going to end up with just 6 to the 3/3, which is 6 to the first. This process allows us to keep numbers rather small. Instead of multiplying 6 and 36 and getting 216 and taking the third root of that, I can think of it as my exponents and use my exponent rules to make my life a little easier. We can also take multiplication as, say, 2 times 8 to the 2/3 power. Here, to simplify this, I would take the 8, make it the third root of 8, and square that answer. The third root of 8 is 2, so I have 2 times 2 squared. 2 times 2 squared is the same as 2 times 4, and 2 times 4 is 8. And there's my final answer. Finally, let's go ahead and take a look at what would happen if we were given a decimal as our exponent. Well, 1.5, if I had 16 to the 1.5, I could rewrite this as 16 to the 3/2. since 3 over 2 is the same as 1.5. Now, my problem becomes the square root of 16 to the third power. Square root of 16 is 4 to the third power, gives me 64. And there's my final answer. So if we look at a review fairly quickly, we looked at how to change a radical into a rational exponent, and we also looked at simplifying a rational exponent by changing it back to a radical and using our laws that we had learned previously.